Tonight, as you settle into the quiet comfort of evening, you might notice something curious. Time feels different now than it did this morning. The hours of your day might have rushed past in a blur, or perhaps they dragged on endlessly. And now, as fatigue settles into your body and your mind begins to slow, time itself seems to change its pace, stretching and compressing in ways that feel almost dreamlike. This isn't your imagination. Time perception, the subjective experience of how quickly or slowly time passes, is not constant. It fluctuates based on your mental state, your level of fatigue, your attention, your emotions, and the chemical environment of your brain. When you're tired, multiple systems in your brain begin to function differently, and one of the most noticeable effects is that your sense of time becomes elastic, unreliable, strange. You've experienced this countless times. A boring meeting when you're exhausted feels like it will never end, each minute stretching into what feels like 5. But then you blink and realize an hour has somehow vanished. You lie in bed unable to sleep, certain that hours have passed, only to check the clock and discover it's been 20 minutes. Or you drift in and out of consciousness, and time becomes completely unmoored from any objective measurement. Before we explore why this happens, if you're finding comfort in understanding how your mind works, take a moment to like this video and subscribe to Science for Sleeping. It helps us create more content to accompany your rest while exploring the fascinating science of consciousness and perception. Tonight, we're going to understand why fatigue changes your perception of time. We'll discover how your brain normally tracks time's passage through multiple overlapping systems. Why attention and memory are crucial for time perception. How fatigue disrupts the neural clocks that help you estimate duration. What happens to your sense of time as you transition toward sleep. And why understanding this can actually help you rest more peacefully, knowing that the strange relationship between your tired mind and the passage of time is completely normal. This is the science of temporal perception in the fatigued brain, the neuroscience of why minutes feel like hours, and hours vanish like minutes when you're exhausted. So breathe deeply, let your tired body settle, and let's explore why time itself seems to change when you're weary. Section 1. The brain's clock. How we normally perceive time. Unlike your sense of sight or hearing, which have dedicated organs, your perception of time has no single biological clock. There's no time organ in your brain, no temporal lobe specifically for tracking seconds and minutes. Instead, time perception emerges from multiple brain systems working together, creating your subjective experience of duration and temporal flow. At the most basic level, your brain uses what neuroscientists call pacemaker accumulator models. Think of it like this. Certain neurons fire rhythmically like a metronome, creating pulses. Other neural circuits count these pulses. The more pulses accumulated, the more time you perceive as having passed. It's a neural clock built from the rhythm of brain activity itself. These neural oscillations happen at different frequencies in the different brain regions. Some fire dozens of times per second. Others cycle more slowly. Your brain integrates these various rhythms to create a sense of time passing. It's like an orchestra where different instruments play at different tempos, but together they create a coherent temporal structure. The striatum, deep in your brain center, plays a crucial role in time perception, particularly for intervals of seconds to minutes. This region contains neurons that respond to specific durations, like neural stopwatches calibrated to different time spans. Some neurons fire strongly when about 3 seconds have passed. Others respond to 5 seconds, or 10 or 30. Your cerebellum, traditionally associated with motor control and balance, also contributes to timing. It helps with precise timing of movements and the perception of brief intervals, milliseconds to seconds. Damage to the cerebellum can impair people's ability to judge short durations accurately. The prefrontal cortex, your brain's executive control center, is crucial for longer time perception and for consciously estimating how much time has passed. This region maintains attention, monitors ongoing experience, and integrates information from other timing systems to create your conscious sense of duration. As you rest here, all these systems are working right now, creating your experience of time passing. Neurons firing rhythmically, accumulator circuits counting pulses, different brain regions communicating to generate the feeling that time is flowing forward, that moments are succeeding one another, that this present moment is becoming the past as the future becomes present. But here's what's crucial for understanding why fatigue changes time perception. All of these timing systems depend on brain resources that become depleted when you're tired. They require attention, working memory, consistent neural firing rates, and stable neurotransmitter levels. When fatigue disrupts these resources, your internal clocks start to malfunction. Attention is particularly important for time perception. When you pay attention to time itself, when you're consciously monitoring duration, your pacemaker neurons tend to fire faster. More pulses accumulate in a given objective period, so time feels like it's passing more slowly. This is why a watched pot never boils, why waiting for something when you're bored makes time drag endlessly. Conversely, when your attention is absorbed by engaging activities, fewer pulses are accumulated. You're not monitoring time, so your brain doesn't encode duration as precisely. This is why time flies when you're having fun, why hours can vanish when you're deeply focused on something interesting. Memory also plays a crucial role. Your sense of how much time has passed depends partly on how much happened during that time. If you have rich, detailed memories of events, the period feels longer in retrospect. If few memories formed, the time seems brief when you look back on it. This creates a strange asymmetry. Boring periods feel long while you're in them, but short in memory, while exciting periods feel brief in the moment, but long when remembered. Your emotional state modulates time perception too. Fear and arousal speed up your internal clock, making time seem to slow down. This is why dangerous or exciting moments feel like they unfold in slow motion. Your brain is processing information faster, creating more detailed memories, and your pacemaker neurons are firing more rapidly due to heightened arousal. All of this normal time perception machinery begins to break down when you're tired. The systems don't fail completely, but they become inconsistent, unreliable, subject to strange distortions. And that's when time starts to feel elastic and strange. Section 2. The Tired Brain. How Fatigue Disrupts Neural Timing. When you're tired, multiple changes occur in your brain simultaneously, and many of them directly impact the neural systems responsible for time perception. Understanding these changes helps explain why time feels so different in your current state of weariness. First, neural firing becomes less consistent. When you're well rested, neurons fire in relatively predictable patterns. But as fatigue accumulates, neurons become more variable in their activity. They might fire bursts followed by longer silences. Their rhythmic oscillations become less regular. This inconsistency affects the pacemaker neurons that form the basis of your time perception. If the neural metronome that's supposed to tick steadily starts speeding up and slowing down unpredictably, the pulses accumulating in your temporal circuits become unreliable. Sometimes more pulses accumulate than should, making time feel slower. Sometimes fewer pulses accumulate, making time seem to pass quickly. The clock itself becomes erratic. Neurotransmitter levels also change with fatigue. Dopamine, which plays important roles in motivation and time perception, decreases when you're tired. Lower dopamine is associated with time seeming to pass more quickly, possibly because the pacemaker runs slower with less dopamine to drive it. This might explain why exhausted hours can vanish in what feels like minutes. As you breathe slowly here in your fatigue, your dopamine levels are lower than they were this morning. Your brain's reward systems are depleted. This affects not just your motivation, but your very sense of time's passage. Adenosine accumulates in your brain throughout the day. This molecule builds up as a byproduct of neural activity and energy use. High adenosine levels promote sleepiness by binding to receptors that slow neural activity. This is why you're tired right now. Adenosine is telling your brain it needs rest. But adenosine also affects time perception. By slowing neural activity, it can slow the pacemaker neurons that help you track time. Fewer pulses per objective second means time might feel like it's passing faster. Alternatively, the decreased neural activity can impair your ability to estimate duration accurately, making time feel vague and uncertain. The prefrontal cortex, crucial for time perception and executive function, is particularly vulnerable to fatigue. This region shows decreased activity when you're tired, measured by reduced blood flow and glucose metabolism. Since the prefrontal cortex helps you consciously monitor and estimate time, its fatigue-related impairment directly disrupts your temporal awareness. Working memory, which depends on the prefrontal cortex, also declines with fatigue. Time perception often requires holding information in working memory, comparing current states to previous states, tracking sequences of events. When working memory is impaired, these temporal processes become less reliable. Your attention becomes less stable when tired. You might find your mind wandering more, attention drifting from one thing to another without conscious control. Since attention directly affects time perception, making time feel slower when you're monitoring it and faster when you're not, this attentional instability creates temporal inconsistency. The default mode network, a brain system active during mind-wandering and internal thought, becomes more dominant when you're tired. This network is associated with different time perception than focused external attention. Some research suggests the default mode network is less precisely calibrated for timing, which might contribute to the temporal vagueness you experience when exhausted. Fatigue also affects your circadian rhythms, the approximately 24-hour cycles that regulate many biological processes. Your circadian system influences alertness, body temperature, hormone levels, and also time perception. At night, when circadian signals promote sleep, time perception can be altered even beyond the effects of fatigue alone. There's evidence that people perceive time differently at different points in their circadian cycle. Some studies suggest time feels like it passes more slowly in the evening and night compared to morning and afternoon. This might relate to body temperature, which follows circadian patterns and has been linked to the speed of the internal pacemaker. As you rest here in the evening, your body temperature is dropping, part of the normal preparation for sleep. This physiological change might be subtly affecting your temporal perception right now, making each moment feel slightly different than it would at midday. The combination of all these factors, neural inconsistency, neurotransmitter changes, adenosine accumulation, prefrontal cortex fatigue, working memory impairment, attentional instability, default mode dominance, and circadian influences, creates the complex temporal distortions you experience when tired. Time becomes unreliable, elastic, strange. Section 3. Waiting when tired. Why time drags. When you're exhausted, one of the most frustrating experiences of fatigue is how slowly time can pass when you're tired and bored. A long meeting at work, a tedious task you must complete, waiting for something while exhausted. These situations can make minutes feel like hours. Understanding why this happens reveals something fascinating about the interaction between attention, arousal, and temporal perception. When you're tired and engaged in a boring task, you're in a state of conflict. Your brain wants to sleep. Adenosine is signaling that rest is needed. Your neural resources are depleted. But you must remain awake and attentive, at least partially. This conflict creates a particular kind of temporal distortion. Because the task is boring, you have little intrinsic motivation to pay attention to it. Your mind wants to wander, to think about other things, perhaps to fantasize about sleep. But you must maintain some attention to avoid completely failing at the task. This means you're partially monitoring time itself, aware that you're waiting for the task to end, consciously noting that time is passing slowly. As we discussed earlier, monitoring time makes it pass more slowly. When you pay attention to duration itself, your pacemaker neurons fire faster and accumulate more pulses. But when you're tired, this effect can be amplified because your depleted brain has fewer resources to engage with the boring task, so more attention spills over into time monitoring. You check the clock. Only 5 minutes have passed, but it felt like 20. This makes you more aware of time, which makes you monitor it more closely, which makes it pass even more slowly. You've entered a feedback loop where awareness of time's slowness makes you more aware of time, which makes it slower still. As you breathe here in the comfort of rest, imagine how different this moment feels from those exhausting periods of waiting. Right now, you're not trying to stay alert. You're allowing yourself to drift. Time might feel vague, uncertain, but not painfully slow. The difference is that you're not fighting your fatigue or monitoring duration. The particular torture of tired waiting also involves emotional factors. Frustration, impatience, and the desire for something to end create arousal that affects time perception. Negative emotions when you're tired can make time feel even slower because they create a state of vigilant monitoring, your brain repeatedly checking whether the unpleasant situation has ended yet. There's also a metacognitive component. When you're tired, you're often aware that you're tired, thinking about how exhausted you feel, how much you want to rest. This self-reflection takes up mental resources, further depleting your capacity to engage with boring tasks and increasing the proportion of attention that goes toward monitoring time. Your depleted glucose levels might also play a role. The brain uses glucose for fuel, and after a long day, glucose levels can be lower. Some research suggests that low glucose impairs the brain's timing systems, potentially making time perception less efficient. Your brain has to work harder to estimate duration when its energy supply is low. The anterior cingulate cortex, involved in effort and conflict monitoring, shows increased activity during effortful tasks when you're tired. This region is essentially tracking the cost of staying awake and working. This heightened monitoring of effort might contribute to time feeling slower, because you're acutely aware of how much effort each moment requires. Interestingly, the temporal distortion of tired waiting isn't constant. You might notice that time seems especially slow at first, but then you fall into a kind of exhausted trance where time becomes vague. Minutes can vanish in a blur of fatigue-induced dissociation. Then something catches your attention, and you become aware again, and time slows once more. This fluctuation reflects the unstable nature of attention and arousal when you're tired. You oscillate between states of effortful engagement, where time drags, and states of near sleep, where time becomes undefined. Your temporal experience becomes fragmented, inconsistent, strange. Understanding this can be oddly comforting. When you're trapped in tired waiting and time feels unbearably slow, you can recognize this as a predictable consequence of the neuroscience we're exploring. Your brain is depleted, your pacemaker is irregular, your attention is conflicted. The slowness isn't reality, it's perception. And like all perceptions, it will change. Section 4. Time vanishing. When hours disappear into fatigue. While time can drag endlessly when you're tired and bored, the opposite phenomenon is equally common and perhaps more mysterious. Hours of your day might vanish into what feels like minutes. You look at the clock expecting little time to have passed, only to discover that hours have somehow disappeared. How does fatigue make time compress this way? This temporal compression often occurs when you're tired but engaged in something that requires minimal attention. Perhaps you're scrolling through your phone in a state of exhaustion, barely registering what you're seeing, your brain in a kind of autopilot mode. Or you're doing a routine task that requires little conscious thought. Your mind wandering while your body goes through familiar motions. In these states, you're not encoding many detailed memories. Your tired brain is conserving energy by processing information at a minimal level. You're perceiving enough to function, but you're not creating rich, detailed memory traces of your experience. And as we discussed, memory is crucial for retrospective time perception. When you later try to recall this period, you find very few memories. The hours are blank, vague, containing few distinct moments or events. Your brain interprets this lack of memory as meaning little time passed. After all, if nothing much happened, it must not have been very long, even though objectively hours elapsed. As you rest here, allowing your mind to drift, you might already be experiencing this. If asked later how long you've been listening to this video, you might underestimate significantly. The relaxed state, the minimal encoding of specific events, the gentle drift of consciousness, all of this will compress into a brief memory that feels shorter than the objective time. Micro-sleeps contribute to temporal compression too. When you're extremely tired, your brain can slip into brief periods of sleep lasting a few seconds, often without your awareness. You might be sitting in a meeting, eyes open, and experience a microsleep where a few seconds vanish completely. Your consciousness simply gaps, and when you're aware again, time has jumped forward. Multiple microsleeps in a period can make time feel compressed because chunks of objective time are simply missing from your experience. It's like a film with frames removed. The narrative jumps forward, and you're left with a disorienting sense that time moved faster than it should have. The default mode network, which becomes more active when you're tired and not focused externally, processes time differently than focused attention states. Some research suggests that when the default mode network dominates, time perception becomes less precise and durations tend to be underestimated. The internal mental wandering of fatigue might inherently compress time. Reduced dopamine when you're tired also plays a role. Lower dopamine is associated with faster subjective time and underestimation of durations. Your neural pacemaker might literally be running slower, accumulating fewer pulses per objective second, creating the perception that less time has passed than actually has. Attentional blinks are another factor. When you're tired, your attention isn't sustained smoothly, but flickers on and off. During the off moments, you're not consciously processing time. These gaps accumulate, and the portions of time you were unconsciously processing get compressed or eliminated from your temporal experience. There's also the phenomenon of change blindness, where you fail to notice changes in your environment because attention is impaired. When you're tired, you might not notice many changes that would normally mark time's passage. Fewer noticed changes create fewer temporal markers, making the period feel shorter than it was. The hippocampus, crucial for memory formation and also involved in time perception, shows reduced activity when you're sleep-deprived. This might impair your ability to construct coherent temporal sequences of events. Without a clear sequence, time feels compressed, vague, difficult to estimate. Interestingly, the compression often becomes apparent only retrospectively. While experiencing the hours, you might not feel like time is moving unusually fast. You're just existing in your tired state, barely aware of temporal flow. Only later, when you realize how much objective time passed, does the compression become obvious. This creates an interesting paradox. In the moment, tired time might feel normal or even slow if you're monitoring it. But in memory, it compresses dramatically. The same period can feel long while living it and short when remembering it, depending on how attention was allocated and how memories formed. Understanding this can help you make peace with the strange temporal experiences of fatigue. Those vanished hours aren't lost. They happened. Your brain was just conserving energy by not encoding them in detail. It's a natural response to depletion, a way of getting through exhaustion without overloading an already taxed system. Section 5. The Twilight Zone. Time at the edge of sleep. Perhaps the strangest temporal distortions occur in the transition between wakefulness and sleep. This liminal state, which you might be entering right now as you rest here in comfort, creates temporal experiences unlike any other. Time becomes fluid, non-linear, almost dreamlike, even before actual sleep begins. As you drift towards sleep, your brain transitions through several stages. First is relaxed wakefulness, where you're still conscious but beginning to let go. Then comes the hypnagogic state, that twilight zone between waking and sleeping where consciousness becomes strange and fluid. Your brain shows changes in electrical activity, shifting from the faster beta waves of alertness toward the slower alpha and theta waves associated with drowsiness and light sleep. In the hypnagogic state, time perception becomes profoundly unreliable. Minutes can feel like hours, or hours like minutes. Often, time becomes completely undefined, neither fast nor slow, but simply unmoored from any measurable flow. You exist in an eternal present that seems to stretch indefinitely. This happens partly because the prefrontal cortex, which helps maintain temporal awareness, becomes less active as you approach sleep. Without the prefrontal cortex providing executive oversight, other brain systems operate more independently. The result is that time perception loses its coherent structure. The thalamus, which regulates consciousness and the flow of sensory information, changes its activity patterns as you drift towards sleep. It begins to gain information differently, allowing some signals through while blocking others. This creates a fragmented experience where awareness flickers on and off, and with it, temporal awareness fragments too. As you breathe slowly here, perhaps already entering the hypnagogic state, your sense of time may be becoming vague. You might not be sure how long you've been listening. The boundaries between moments might be blurring. This is your brain naturally transitioning away from precise temporal tracking. Hypnagogic hallucinations, which many people experience as they fall asleep, further distort time. You might have brief dreamlike experiences, vivid images or sounds that seem to last a long time but occur in just seconds. When consciousness returns enough to realize you were hallucinating, you discover that almost no objective time passed. Even though the experience felt extended, the temporal distortion of the hypnagogic state is why lying in bed, unable to sleep, creates such confusion about duration. You're in and out of consciousness, drifting through the twilight zone repeatedly. Each time you check the clock, you're surprised by how much or how little time has passed. Your brain has been transitioning toward sleep and back, and during those transitions, temporal tracking becomes unreliable. People often experience time dilation in the moments before sleep, where seconds feel stretched. This might occur because the slowing of neural activity slows the pacemaker neurons, but consciousness remains just aware enough to notice the altered flow. Each moment becomes thick, syrupy, extending in a way that feels almost psychedelic. There's also the phenomenon of dream time compression. Once you're actually asleep and dreaming, elaborate narratives can unfold that seem to take hours, but occur in minutes or even seconds of real time. The sleeping brain processes events differently, creating temporal structures that don't correspond to clock time. This dream time compression sometimes bleeds into the hypnagogic state, creating experiences where complex scenarios seem to unfold in the instant before you catch yourself and realize you were drifting. These micro-dreams can feel like they lasted much longer than the few seconds they actually occupied. The circadian system's influence is particularly strong in the evening transition towards sleep. Your body temperature is dropping, melatonin is rising, and multiple hormonal changes are occurring. All of these affect neural function and consequently time perception. The evening and night have different temporal qualities than day, partly due to these circadian factors. Some research suggests that the subjective feeling of time slowing down as you fall asleep might be adaptive. By stretching out the moments before unconsciousness, your brain might be creating a buffer zone, ensuring that you're truly safe and comfortable before surrendering to sleep's vulnerability. The extended moments allow for final checks and adjustments. As you continue to rest here, allowing the hypnagogic state to deepen if it hasn't already, notice how time itself might be changing quality. It's not disappearing, but transforming, becoming less linear, less measurable, less defined. This is normal. This is your brain preparing for sleep by releasing its grip on temporal structure. Section 6. Making peace. With temporal distortion, rest in the elastic moment. As we complete this exploration of fatigue and time perception, let's return to where you are right now. Tired, resting, experiencing time in ways that might feel strange or disorienting. Understanding the neuroscience behind these temporal distortions can help you make peace with them, accepting the elastic nature of time when you're exhausted. First, recognize that your time perception is not reality. Clock time continues at its steady pace regardless of how you experience it. When time feels slow, it's not actually moving slowly. When hours vanish, they still happened. The passage of time is objective, but your experience of it is thoroughly subjective, shaped by neural processes that fatigue disrupts. This distinction is liberating. If you're lying in bed and time feels agonizingly slow, you don't need to fight that perception or be frustrated by it. You can acknowledge it as a neurological phenomenon, a predictable result of the brain states we've explored. The slowness is in your perception, not in reality, and like all perceptions, it will shift and change. Similarly, if you feel like the day vanished in a blur of exhaustion, you don't need to feel like you've lost time or wasted it. Your brain was conserving energy by not encoding detailed memories, a reasonable response to depletion. The time was lived, even if it left few memory traces. As you rest here, breathing slowly, you can practice accepting whatever temporal experience arises. If time feels slow, let it be slow. If time becomes vague and undefined, let it be vague. If you lose track of duration completely, that's fine. There's no correct way to experience time in this moment. Your tired brain will perceive it however it perceives it. This acceptance can actually help you rest more effectively. Much of the frustration with insomnia and fatigue comes from fighting your brain's altered states, trying to force it to work normally when it's depleted. But your brain doesn't need to track time precisely right now. It needs to rest. Releasing the need for temporal accuracy is part of releasing into sleep. Understanding the neuroscience also helps you recognize that extreme temporal distortion might signal that you need rest. If time frequently feels very strange, if you often lose hours to fatigue, if temporal awareness becomes regularly unreliable, your brain might be telling you it's chronically depleted. Sleep might need to become a higher priority. The elastic nature of time when tired isn't a malfunction. It's your brain operating in a different mode, one adapted for conservation and rest rather than precise temporal tracking. The neural resources needed for accurate time perception are being redirected or powered down to preserve energy. This is adaptive, not pathological. There's even something philosophically interesting about these temporal distortions. They reveal that your experience of time is constructed, created by your brain from various inputs and processes. Time isn't something you passively perceive like color or sound. It's something your brain actively generates, and when the generation process is disrupted, time itself becomes fluid. This means that the nature of time, at least as you experience it, is more flexible and subjective than everyday experience suggests. The rigid, uniform flow of clock time is just one way of experiencing temporal passage. Your tired brain reveals other ways where moments stretch or compress, where sequences become unclear, where the present moment expands to fill awareness. As you drift deeper into rest now, perhaps approaching sleep, you can let time become whatever it needs to be. You don't need to know how many minutes have passed, or how many remain until you fall asleep. You don't need temporal accuracy or precision. You need rest, and rest has its own temporal quality that doesn't correspond to clocks. The hours of sleep ahead are strange from a temporal perspective. You'll be unconscious for many hours, but they'll pass in what feels like an instant. You'll close your eyes, and then you'll open them, and the entire night will have vanished. Within that vanished time, you might have dreams that feel like they last hours. Time in sleep is profoundly non-linear. But that's fine. That's what sleep is. A release from normal temporal experience. A surrender into a state where time doesn't need to be tracked or measured. Your brain needs this break from temporal awareness just as it needs a break from sensory processing and motor control. Tomorrow, when you wake rested, your time perception will normalize. The neural systems will be replenished. Neurotransmitters will be restored. Your pacemaker neurons will fire more consistently. The prefrontal cortex will resume its executive functions. Time will feel more stable, more predictable, more like the uniform flow you're used to. But tonight, in your fatigue, time is elastic, and that's perfectly okay. Let it be elastic. Let it stretch or compress or vanish or become undefined. Your tired brain is doing what it needs to do, and part of that is releasing its grip on precise temporal tracking. Sleep well, knowing that the strange time you're experiencing is normal, is neuroscience. Is your brain taking care of itself by letting go of the demanding work of temporal precision? Rest in the eternal present that has no duration, no beginning, no end, just this moment of peace stretching out into timeless rest. Good night, and may your sleep be deep and restorative. And may time become whatever it needs to be as your consciousness releases into dreams.